x is equal to y plus p square. Here, observing this problem, this is a non-linear differential equation which can be solvable with the help of solvable for x method, or we can solve this equation with the help of solvable for y method, because here only one x term and only one y term. Take the given problem x is equal to y plus p square. Here I am applying the solvable for x method. Here this is an equation of the form x is equal to f of y comma p. So that call this as equation number 1. First step is completed, that is already this is an equation of the form x is equal to f of y comma p. So second step is you have to differentiate this equation with respect to y. We get here differentiation of x with respect to y is dx by dy, which is equal to, here differentiation of y is 1 plus differentiation of p square is 2p into dp by dy. Next step, we know that dx by dy we can write it as 1 by p, which is equal to 1 plus 2p into dp by dy. Take this 1 to the left hand side, that becomes 1 by p minus 1, which is equal to 2p into dp by dy. Next step, take this y to the left hand side and 1 by p minus 1 goes to the right hand side, that becomes 2p divided by 1 by p minus 1 into dp, that is dy, which is equal to 2p divided by 1 by p minus 1 into dp. Here take LCM as p and simplify, we get as dy, which is equal to 2p divided by 1 minus p divided by p into dp. This p goes to the numerator, we get as dy, which is equal to 2p square by 1 minus p into dp. Here this is a equation which contains y in one side and p on other side. Now we can integrating with respect to p and y separately, we get as integration into dy, which is equal to integration of 2p square by 1 minus p into dp. Here in the right hand side we have to integrate 2p square by 1 minus p. If we take 2 outside the integration, remaining is p square by 1 minus p. So to make the simplification easy, we can take in the place of p square as p square minus 1 plus 1. If we cancel plus 1 minus 1, we get a value as p square itself. So in the place of p square, write it as p square minus 1 plus 1. So here we know that p square minus 1, this is of the form a square minus b square, that is a plus p into a minus b. We can write it as a plus p into a minus b. In the place of a we have p and b as 1. So we get as p plus 1 into p minus 1 plus 1. So in the place of p square we can write it as p plus 1 into p minus 1 plus 1. Here we get as, take 2 outside the integration. Here integration of dy is equal to 2 into integration of, in the place of p square we can write it as p plus 1 into p minus 1 plus 1 divided by 1 minus p into dp. Now we can split the value as integration of p plus 1 into p minus 1 by 1 minus p plus integration of 1 by 1 minus p into dp. That is integration of dy, which is equal to 2 into integration of, here we have p plus 1 p minus 1 term. In the denominator we have 1 minus p. So we have to take it as p minus itself. So take minus as common, we get in the denominator as minus of p minus 1 plus, here also integration of 1 divided by, here also we have to take minus common, we get as minus into p minus 1 into dp. Next step, here p minus 1 in the numerator, here also p minus 1 in the denominator, we can cancel. Here also minus sign, here also minus sign, take minus sign outside the integration, we get as integration of dy, which is equal to minus 2 into integration of, here is p plus 1 plus, here we have 1 by p minus 1 into dp. Next step, split the integration, we get as integration of dy, which is equal to minus 2 into integration of p plus 1 into dp plus integration of 1 by p minus 1 into dp. Next we get integration of dy is y, which is equal to minus 2 as it is, into integration of p plus 1 is, here integration of p is p square by 2 plus, here integration of 1 with respect to dp is p plus integration of 1 by p minus 1. This is of the form 1 by x, integration of 1 by x is log x. So in the place of x we have p minus 1, that is log of p minus 1 plus some integration constant c. Call this as equation 2. In the first problem, we can easily obtain the p value, so that we can substitute in equation number 1, we get a general solution which does not contain p. But here we get an equation which is so complicated to find the p value. So consider in equation 1, that is equation 1 is x is equal to y plus p square. So x is equal to y plus p square, which implies p is equal to, here x minus y is p square. So we get p value as square root of x minus y. So from the equation number 1, we can substitute p value as root of x minus y. Substitute in the equation 2, p value as root of x minus y, we get as y is equal to minus 2 into P is square root of x minus y whole square. Here P square is square root of x minus y whole square divided by 2 plus P is square root of x minus y plus log of P is square root of x minus y minus 1 plus some integration constant c. So this is a general solution for a given differential equation because here this equation does not contain P. This completes the problem.